Alright, so in the last section, we figured out what a system of equations actually was, and we decided it was two or more equations with two or more variables, and those variables are related to each other. So if I'm trying to solve a system like this guy, I'm trying to find the x value and the y value that satisfy both equations. In other words, there's hopefully one x and one y that make both of them true. And we said, we can guess and check, but we might be guessing and checking for a really long time. A valid strategy, but maybe not the most efficient. One really good way to tackle this is by graphing. And remember that graphing means making a picture of the solutions. Now, this is really easy to do. We just have to graph the two lines, and hopefully we'll be able to pick our solution off of the graph. I know you know how to graph lines already, and the key step is to make it easy to graph is we need to solve the equations for y. Y equals mx plus b. Much easier to graph if we do that. So for the first one, 3x minus y equals 3. I'll need to subtract 3x from both sides to get y by itself. So negative y equals negative 3x plus 3. And then I'll need to divide through by negative 1 to get it so it's positive y equals, not negative y equals. And so I'll end up with y equals 3x minus 3. Now I can go ahead and graph that line. And the y-intercept's negative 3. So I'll put a dot there at negative 3. And the slope is 3, also known as 3 over 1. So I'll go up 1, 2, 3 over 1. And forgive me, working with this stylus, it's pretty hard to get accurate graphs. It would be much easier if I had a ruler. But when I do this, I should end up with a line that is something like this. Okay, again, not real accurate. And by the way, that is the weakness of this strategy. The strategy works well, but it really lives and dies by the fact that your lines are accurate. And if your lines have, if they're not a real, well, you'll see in a minute. We'll keep going here. Okay, for the second equation, I've got x plus 2y equals 8. So we'll minus x from both sides. So 2y equals negative x plus 8. And y is almost by itself, but I have to divide through by 2. So y equals, now keep in mind, this right here is really negative 1x over 2, or negative 1/2 x. And then 8 divided by 2 is 4. And so I end up with y equals negative 1/2 x plus 4. And so I'll go to graph that. So I'll graph here at plus 4. That's the y-intercept. And I'm going to go down 1 and over 2. So there's another point. 2 points make a line. And I will draw this line in. And you can see there I totally missed my points. But if I was to move that line down, if I had the ability to do that, I'm guessing I would have gotten an intersection right about here at point 2, 3. Okay, that one just kind of hard to see, but that says 2, 3. Now, keep in mind, the white line, that's all the things, all the x, y's that make the first equation true. So, for example, point 0, negative 3, that's a point on the white line. That would make the first equation true. And all the points on the purple line make the second equation true. So, for example, right here, I have 0.40. And that will satisfy the first equation. And so maybe you've already figured out where I'm going with this, but if I look at the intersection point, this spot right here, I end up with the 1x and 1y that makes both equations true. Okay, that's the one point, that intersection. So we've got all the solutions to the white equation, all the solutions to the purple one, and the intersection is the one that works for both. And so that looks like that's about 0.23. And so I can conclude that x equals 2, y equals 3 as the solution to my system. Again, and you can plug those numbers in and we can check and see that they work, but they do. And the downside with graphing is that you got to graph accurately, and it might not always be easy to pick that solution up from the graph. But it's a valid strategy, and it's a good way to verify a solution or solve it in the first place. So, but easy to do. In summary, graph the two equations, see where they intersect, that's your solution, the one solution they share. Now there's a couple of special cases here, and I'm going to go through these fairly quickly. With these two, I've got another set of systems, and I'm going to solve these both for y. Now, I'll have you trust me on this. We're going to have y equals 2x minus 1 if I solve the first one for y. And the second one is going to be y equals 2x minus 1. Now, that's interesting, right? Because I sounded like I was repeating myself there. But what happens is it turns out when you solve these for y, you end up with the same equation. Turns out that both of those problems happen to be the same line. So when you go to graph it, like the first one, y-intercept is -1, and you're going to go up 2 over 1. Another point, you're going to get some sort of a line like this. When you go to graph the second one, you're going to get the same line, of course. Same equation gives you the same line. So that means that all points intersect. In other words, there's not just one solution to this. All the points make solutions, and your answer here would be infinite solutions, since there's infinite points on a line. Okay, so this is the case where you graph these and you happen to get exactly the same equation, which means you have exactly the same line, so infinite solutions. So most of the time, these are going to intersect at one point, and that's your solution. But in some cases, they may be the same line, and you'll have infinite solutions. Now, last example here, and again, I'm going to be brief. This one, just for the sake of brevity, I've already solved these for y, and let's take a look at these two lines. So the first one, y equals 3x minus 1. So -1 up 1, 2, 3 over 1, and we're going to get a line that looks about like this. And then for the second one, y equals 3x plus 4. So plus 4 and up 1, 2, 3 and over 1. And there's our second point, and this line's going to look something like this. Now, notice these lines have the same slope. And same slope means that they are parallel. And if they're parallel, that means no intersection. And because, all the solutions to one equation are here, the other equation are here, there's no point of intersection. That means there's no point that they share in common, which means that there is no solution. So the lines are parallel, means they can't intersect, and because they can't intersect, that means that there's no x and y that they share. And again, we didn't have to solve these for y. We got lucky, and I gave you equations that were already solved for y, and that'll happen in your assignment too, but probably by and large, you'll have to solve them for y before you graph them. So in summary, most of the systems of equations that you graph are going to, you're going to solve them for y and find one intersection point, one solution that they share. In some cases, they may be the same line, which means all the points intersect and you have infinite solutions. Or it's also possible that the lines will have the same slope, they'll be parallel, which means there'll be no intersection point and you'll have no solutions. There's other ways to solve systems of equations too, but graphing's a pretty good one. The only weakness is sometimes it can be hard to pick the point off the graph that's the solution.